Welcome to my YouTube channel. The lesson this time around, I'll be looking at how to find the resultant of more than two forces. I'm sure I've been following my lessons. I started by talking about vectors, how to represent a vector, and then we're looking at now how to find the resultant of more than two forces. You see a system of forces here acted upon by one, two, three, four. And there's a body here at point O. This is just a free body diagram of this system of forces acting on this body at point O. Now we want to find a resultant. What's the total force acting on this body? And I've decided to define my angle theta, that is the direction of each force. Let my angle theta become the angle between the vector, angle between the force line, and the horizontal. Some other persons or some other teachers can decide to define their own otherwise, but I'm choosing this definition. My angle theta is the angle that the vector, that is the direction of each vector, is the angle it makes with the horizontal axis, that's the x-axis. The direction of 45 Newton is 30. The direction of 60 Newton is 50 degrees. The direction of 55 Newton is 90 degrees. Angle it makes with the horizontal, this is 90 degrees. And the direction of 30 Newton, I need to define this angle. I want the situation whereby my angle theta, that is the direction of each vector, is the angle that the vector makes with the x-axis. So since this is a right angle, I've given it this point as this is 60 degrees, then this will be 30 degrees, so that 30 plus 60 gives you 90. Okay, so very quickly, I want to use this method to resolve or to find the resultant of this number of forces. I prepared this table beforehand. So here I can start with the 45 Newton. I place 45 here. So here I have the force of 45 Newton. The angle it makes with the horizontal is 30 degrees. So I write here 30 or 30 degrees if I wish to. Now I'll resolve this. On the previous video I taught you how to resolve a vector. If you don't know that, maybe this is the first time you are watching this, please quickly refer to that video where I taught how to resolve a vector, a force, into two perpendicular components. So I'm going to find the fx component, or let's say this is fy component, that is the vertical component of 45 Newton, and the component of this 45 Newton acting horizontally. I call that fx. Okay, so using my SOHCAHTOA, this is sine 30 degrees equals opposites over hypotenuse. Okay, so the 45 Newton occupies the hypotenuse side. So what's my Fy? Fy becomes 45 sine 30. So I'll come here now along in my vertical component column. I'll put here 45 sine 30. Okay, if I evaluate 45 sine 30, it gives me 22.5 because sine 30 is 0.5. 0.5 times 45 gives you 2.5. Then my fx component, the component of this vector, just like you have this now. I used to tell my students, put your pen such that the tip points the direction the pen is acting. You can move this pen horizontally. That is, you are resolving that you are looking at a part of this vector 45 Newton that is acting horizontally. That is resolved horizontally. And then the same vector has some component acting vertically. So since the two components are pointing in this direction for x-axis, and then this one is pointing upward, it means the two components will be positive. So this is adjacent to hypotenuse, that's the cosine component. That gives me 45 cos 30. And 45 cos 30 is roughly approximately 39.0. Okay, I'll move to the next vector. Call that, okay, let's go back to the diagram. The next vector is 60 Newton. Let me use 60 Newton. I write 60 Newton as the force. And the angle it makes with the horizontal is 50. If this was given, let's say 40, this is what was given. I'm not going to use this 40. I hope you know. I've already defined my angle theta, that is the direction of each vector, as the angle that vector makes with the horizontal x-axis. So if I was given this, I would have used this 50. But a good thing, I was given this as 50 degrees, so I'm going to use that as my direction of the 60 Newton force. So by the time I resolve this, okay, let's say I do something like this. I draw this to make up a right angle triangle. This is my fx, sorry, this is my fy component, and this is my fx component. So that is opposites over hypotenuse. So my F, but when I place my pen like this, I resolve it vertically. It means that the Fy component is pointing upwards. Any vector pointing in the upward direction along the positive y-axis is taken as positive. So that will give me, this is opposite of hypotenuse, that is sine Fy equals 60 sine 50. That gives me here, I'll come here, right, 60 sine 50. And 60 sine 50 is roughly 46, that is 46. Okay, so need to come back and look at my fx component, that is adjacent over hypotenuse, that is cosine. Adjacent of hypotenuse, that is cosine. That gives me 60 cos 50. Now you need to watch out something here. Let's come back again. Resolve this vector horizontally. It points along the negative x-axis. If you resolve it, it points this way. So we are going to insert a negative sign here. Negative 60 cos 50. That will give me minus 38.6. That is, you multiply this by this. Okay, the next vector I want to resolve is the one acting vertically downwards along the negative y-axis. Okay, I'll put that as 55 Newton. The direction is 90 degrees. Okay, now this vector is acting vertically downwards. The x component will be 55 cos 90. If you check your calculator, cos 90 is 0. That gives me 0. Remember I told you that one of the videos I did that any vector acting vertically, that is along the y-axis or along the x-axis, they do not have component on the other axis. So this one is acting vertically downwards. It has no component along the x-axis. Okay, let's check and see that. Okay, so the y component is minus 55. Why is it negative? I guess you know why it is negative. Okay, okay, I'm sure that giving me the reason now why it is negative. Okay, so this vector 55 Newton, you can see clearly there that the direction is downwards. If I place the tip of my pen in the direction of the vector, it points downward. Pointing downwards means it's negative. So a vector pointing upwards has a positive value. You know, when it points downward, the negative value, that is the negative sign indicates direction. That gives you minus 55 is the value Newton. Okay, that's for the y component. So let's treat the last vector, which is 30. So I write 30 Newton. The angle it makes, recall I was giving this 60. The original question gave me this as 60, but I'm using the angle the force makes with the 30 degrees. I mean, I'm using the angle it makes with the horizontal, which is 30 degrees. So when I resolve this now, this gives me, I draw this. Now the y component, place your pen like this again. The y component, we resolve this, is acting downwards. That is negative. The y component is negative. That is the vertical component. So I'll come here and put this is minus 30 sine 30. Okay, that will give you minus 15. The y component of this vector 30 Newton, if you resolve it vertically, it points towards or along the negative axis, as you can see here. Okay, so then it's negative. Then the x component, that is the horizontal component adjacent over hypotenuse, that's the cosine component. That gives me, it's positive because it's acting along the positive x direction. That will give me plus 30 cos 30. 30 cos 30 gives me approximately 26 Newton, 26.0. So I've resolved each of the forces given to me into their respective horizontal and vertical components. So the next thing to do is to sum. I'm going to add up the sum of the forces acting along the x direction, that is, and then the sum of the forces acting along the y direction, that is the vertical component. So I'll call this summation x. You know, I'm going to add 39. I'll add 39 to minus 38.6 to 0 and to 26. If I add that, it gives me 26.4. So I will add this to this to this to this. You can try adding it yourself so that we'll be on the same page. So I'll give you some time now. So I know me, I'm very fast because I've already done this thing beforehand. Okay, so if I'm going to find the sum of all the vectors, the components of these forces acting vertically, I'm going to have 22 plus 46 plus minus 15. I'm going to have 22.5 plus 46 minus 55 minus 15. So the answer gives me roughly minus 1.5 Newton. So having got this, the next step is for us to use, or we can redraw this diagram. So which means this system of forces, graphical representation of this system of forces simplifies to this diagram. That is to say, we can simplify this diagram to have something like this. This is my summation, the total components of all these forces acting horizontally, 26.4 Newton. Then the sum of all the forces acting vertically is minus 1.5. That is negative. So I come here and write 1.5. So which means the entire diagram reduces to this system of two perpendicular forces. Along the x-axis is this, along the y-axis is this. So the next thing is for me to, I can make this up to a rectangle in order for me to find the resultant, The diagonal of this rectangle, of course, represents the resultant of these two vectors, which I can, by Pythagoras theorem, r squared gives me summation x squared plus summation y squared. That gives me r equals square root of 26.4 squared plus minus 1.5 squared. Okay, so I need to allow you to apply your calculator here so that you can give me the final result, which will allow you take your time now to give me the. I guess you are done with your results. Mine gave me 26.4. I think that is the resultant vector. The direction, we can take that as this angle. The angle the resultant line makes with the horizontal. From SOHCAHTOA, we have tan alpha equals opposite, which is minus 1.5. This is also 1.5 because this side is 1.5. This is my opposite, this is my adjacent. Over adjacent 26.4. Okay, so maybe I should allow you once again to give me the uh, final answer for the direction of the resultant vector. 1.5 divided by 26.4 gives us 0.0568. Okay, negative. Then alpha, which is the direction, is now evaluated using tan inverse of 0.0568 negative. Recall that the value has the negative sign. Okay, so that tan inverse of that gives me minus 3.25 degrees. Okay, so moving this way. Okay, that is angle. But the positive angle equivalent of this is gotten by subtracting 3.25 from 360. 3.25 degrees from 360. So that is how to get the positive angle of that direction. That will give me 356 degrees positive. Of course, you agree with me that the resultant line is in the fourth quadrant. This is the first quadrant, second quadrant, third quadrant, fourth quadrant. That's the reason why the direction is negative. And the positive angle is by subtracting that from 360. That gives you 356.